In this question, they're asking us to consider ionic character. Ionic character means how much like an ionic bond is it. The greater the difference in electronegativity, the more the ionic character. Notice that we're using the word difference. So if, for instance, you take the very most electronegative element, fluorine, and bond it with another atom of fluorine, there's no difference in electronegativity, even though they're both both atoms would be very, very electronegative. Here they're asking us to rank bromine to bromine, nitrogen to oxygen, calcium to oxygen, carbon to fluorine, and potassium to fluorine. We actually do not need a table of electronegativity values to do this. All we need is a standard periodic table. We're going to note the relative positions of the elements that we're considering. And we're just going to note how far apart they are. So first bond, bromine to bromine. Well, two atoms of bromine, even though bromine is a fairly electronegative atom itself, when it's bonded to another atom of exactly the same type, there's no difference in electronegativity. So I'd say this would be the least ionic character of all of them, because of all the other bonds there's at least some difference. Okay, nitrogen to oxygen, they're one step away from each other. This would be like the next lowest electronegative difference in electronegativity, and therefore the next lowest ionic character. So if we've got 5 bonds, here's what we'll do. I'll rank them. So this is the 5th greatest ionic character. Nitrogen to oxygen, since they're right next door to each other, let's call it 4th place. Calcium to oxygen. Now we're talking about two elements that are pretty darn far apart. But notice they're not quite as far apart as we see with potassium and fluorine. Potassium and fluorine are on completely opposite sides of the periodic table. So the potassium fluoride gets 1st place. The calcium oxygen bond, calcium oxide, would get 2nd place. And then somewhere in the middle we could put the carbon to fluorine. They do have a decent, appreciable difference in electronegativity, but they're only 3 steps away. So you can do this entire ranking based on positions on the periodic table. So in the question they say rank these in increasing order, so that means the least ionic character to most. So I would put bromine to bromine as the least, followed by nitrogen to oxygen, followed by carbon to fluorine, followed by calcium to oxygen, followed by potassium to fluorine.